All right, good morning. In this video, I'm going to show you how to create a spreadsheet to close a traverse. So, first you're going to see what the traverse is. So you just find your relative precision, and then close the traverse. So 1 to 2,500. You're going to close that traverse. So right here we got the line number, the distance of the line, the bearing of the line, and here's how you calculate the departure and the latitude. So I think our sine of radians. Yeah, so the sine of the angle times the distance. And how that works is you got the departure 125, latitude 255, so it's going to look something like that, right? 285 is your the distance. Your bearing there is 26.16. Departure, latitude. So sine 26 is equal to d over 285. Solve for d, you get sine 26 times 285. And in Excel, you got to type in sine radians 26 times 285. So sine radians of 26.16 degrees, close, times 285/10, B5. That's how you get that. And then the latitude's the same, it's just L over, so it's exactly the same, just typing in cosine radians 26 times 285. All right, so now you have the departure and latitude of the first line. So in this case, the origin 0, 0. Typed in PL space 0, 0, just typed it in, just like that. Here, I'm going to type in the equal sign, open quote, at symbol, close quote. That tells it relative from the first point. I'm going to go 125 in the X and 255 in the north, so I got to put a comma in between there. So at, ampersand, D5, ampersand, open quote, comma, close quote for the text of a comma, and then E5. It's real simple. Just putting the at symbol in front of these two with a comma in between. And then we're just going to copy and paste that down like that. We got, that's all done now. So really what we need to do here is just take the sum of all the distances. We're going to need that later, right? Sum of all these, and then multiplying it by -1, because if it's on the right, we need to go left, so you're going the opposite direction of the departure and latitude, so each one of those will be multiplied by a -1. Enter, and relative precision. Thing I didn't put in here, you might want to see is 53 and 7. Let's take, now here's what we can do. We can take this, Control C, Polyline, and then we're going to create a polyline on Autocad. Let's do that right now. So let's see, we're in red. This is our missed closure. Control V, enter. Now you'll see, if we zoom way in here, the diagonal, let's do the horizontal. .53. In the vertical, I think it was 0.7. And then the diagonal is 0.88. But it's not on, that's not, the 88 wasn't shown, so that's why I wanted to show you what it is and where it came from. So right in here, this formula, part of the formula right here, that's the Control C equals Control V, that's the 0.88, right? So what you're doing is you're taking the linear misclosure, 0.88, and dividing it by the total, which would be equals this divided by that, enter, and then you add with this, and you're just going to take that, take 1 divided by that. Open parenthesis, close parenthesis, enter. And then you get the 1 over that, right? 2791, right there. So right here, I just put a 1, put the equal sign, open quote, 1 divided by close quote. That's just telling it there's text there in front of that number that we just got right here, right? If you go back to there, and then the square root was there. Instead of taking it from another cell, I just put the 0.88 inside the cell. There's your relative precision. And then, so what we're going to do now is we're going to get, I'm going to close this up a little bit. We don't need that anymore. So the length here is just taken from here. So it's equal to B5. So I can have it closer to the new work. We got to how to close the departure, and I try to explain it, but I'm not even sure exactly if I remember, so I'm just going to show you the steps. Maybe I took it from the formula. I think at one time I understood it, probably understood it more than once, but don't really understand it now if we're looking at it. But you're going to take D5, you're going to lock that reference, that cell, D12, the sum departure, because we're looking, right now, we're looking for the close departure. So it's relative to the sum departure divided by the sum distance, right? That makes sense. The departure divided by the distance. And then we're going to multiply it by the departure. I'm sorry, we're going to multiply it by the length of the departure, the one departure itself. And then we're going to add it to that departure, the original departure, right? So I can honestly tell you the geometry in my head's not adding up, but this cell divided by this cell, those two are locked reference, right? The sum departure divided by the sum distance. And you're going to multiply it by the length, and then you're going to add it to the departure, okay? All right, there must be some algebra involved because I'm not seeing it in my head. And you're going to do the same thing here for the closed latitude. You're going to take the sum latitude divided by the distance, multiply it by the length, and then add it to the latitude. All right? And then there's that. And then you're going to do the same thing we did over here, just same origin. We're going to start at the same place, PL space 0, 0. And then they're going to put an @ symbol in front of the new departure, new latitude. And we're going to go right here, copy. Let's change it to green. And paste, Control V, enter. Now you see the green line. There's no misclosure on the green line. All right. That's how you do that. Let's see. So here, obviously, the sum distance is a little different. Very, very small. Maybe it doesn't change the distance. I thought it would, but even if it was slightly. Oh, so it's the same column, right? It doesn't matter. So the sum distance probably does change a little bit. I don't have it on here. You can put it on. I don't know that it's necessary. Let's see. So there you go. Some closure of each one of those is 0 now, and the relative precision is 1. Exactly right. Let's see now. So here we got the new bearing, right? So this is using these two cells, the new departure, new latitude. Just going to type in degrees arctangent. So it's sort of like the other one where you got to use the radians in the formula, sine radians. This one you have to tell it degrees arctangent, right? Degrees arctangent, departure divided by latitude, because that's the orientation of the original piece. And that may change. I'm not sure if it did. Let's see. If I went like this. So I've got blue and red. Blue and red. Blue and red. Blue and red. Yeah. So it works out. So oh yeah, because the departure and latitude is always horizontal and vertical. So here we go. So this one here, I'm going to show you this formula. It's very useful. I'm going to close this up a little. I don't need that. And then I'm going to zoom all the way over. I'm going to zoom in. Seems like it should go fast and then slow. All right. So anyways, here's the degrees in decimal degrees. This formula right here will get you from decimal degrees to degrees, minutes, and seconds, just like exactly like it is in that format there. And then that is one valuable little bit of information. I changed the precision here at the end because if it was 53.59 seconds, it rounded it up to 53 degrees and 60 seconds. Some weird thing was happening. So by putting a 01 at the end, I think it got rid of that. And then I just put the north and the easting there so I could copy this text and paste it into the actual drawing. And that's what it is. I think that's pretty much it. The new relative precision is perfect. I don't know, I started to do something about the rotation, and I think that's a nothing. That would be the difference in the first angle, and then you'd have to do the difference in each angle, because the angle changes a little bit depending on the length. I don't think you get a consistent change in the angle. Let's see. So if we do this, the angle between these two, 0.16, enter. I'll do the same thing here. Get back in there. Nope. .46. Yeah, so it changes depending on the length, right? So I think that was something that I started and then stopped, so it doesn't matter. And that's what I know about that. Let's do one real quick thing here. I think we're still pretty quick on time, so 12 minutes. I'm going to show you a quick one here. Let's do create a leader, multi-leader with the coordinates on it. So tools, so let's go format, point style, 1 foot, that's good. Okay, so insert point, PO. All right, and then a line, about 12 and 18. Enter. So let's create, let's go at ATT, enter, tag, size 12, tag it ID, I have to have a default there, I think. All right, and well, they got big. Let's see. That I changed it to, oh yeah, 1, enter. Actually, go probably 2. And then same thing, ATT, coordinate. Not sure which one does what. And then 2, enter, right there. Get a little closer over there. And then we're going to do, let's see, what are we going to do? I'm going to do B, enter, coordinate ID, COORD. And then we're going to pick a point right there. Select objects, select them in this order, enter, turn the block, ID coordinate, okay. So then we're going to type in right here, attribute, insert field. For the coordinate block placeholder, it's going to be an object. The circle, that's the block. We want position. And we want the precision to be 2 is good. X and Y only. You can put in YZ if you're working in 3D stuff, and then hit OK. And that's really hard to see in it. So then let's do this properties point. We want to point there on that breakpoint. Sorry, it's so hard to see. And then action of stretch. So we're going to type in same thing, hit this one, and then circle those, get them all, right? Enter, not the point on the bottom. And then parameter, how about a flip? Right here at the origin. Sorry, you probably can't see that. Flip state. And the action of flip. And then we're going to hit that. And then the whole thing, right? Everything we want it to flip. Enter. Let's move this somewhere up there. And close block editor. Save ID coordinate. Yep. All right. So now we have something that we can put anywhere we want. Let's put it down here on the 0, 0. And let's just check to make sure it updates. Regen 0, 0. So it's working properly. You can take it, move it around like this. Oh, I didn't do it properly, but that's funny. Did it wrong. How's that? This should be, we would want that line to stay parallel. Flip it, and then yeah, so there's a little something going on with the way I selected the lines. So that's a no good. Yeah, that line should be stretching. I'm not sure what I did wrong, but I did a video on it. ID coordinate foot block, something like that. And it was how to do decimal feet. So, but if you just didn't copy and paste the code in there, you would be able to just do it in feet, and it would work. Unfortunately, that last 2 minutes didn't work, so I'm probably going to leave it out. But hopefully this helps you in your career, and share it with, if you can, if someone's interested, please share, and thanks for watching.